All right, so let's get started for today's class. In the last class, what we're looking at is NumPy arrays, and we have covered till slicing. And what we need to look at today is some of the universal operations or universal functions of the matrix. So what we are going to see today is the rest of what is left in NumPy, and that is what we are aiming to finish. The other thing that we will do today is we will see how to handle files, text files or CSV files in Python. And the libraries that we are going to use is definitely not going to be Python. We are going to use a separately different library to be able to handle files. So let's get started with NumPy. Um, so there are a few things, right, that we have looked at yesterday as to how do we slice, how do we do subsetting and stuff like that. But when it comes to metrics, there are a few universal functions which we end up doing, right? And for that, we do not need to do any programming. We can just call some of the existing Python libraries, right? Or the NumPy libraries, if I may say. So let's get started. To begin with, I'll give you a very basic example of what these matrix operations are, and then we can look at it as to how do we do that in Python using NumPy. So, okay. So let's assume we have two matrices, right? We have two matrices. The first one is, let's say, yeah. So let's assume we have two matrices, and these are like the first one is 1, 2, 3. These are 3 cross 3, right? These are 3 cross 3 matrices. So the first one is 1, 2, 3, 4, 5, 6, 7, 8, and 9. So this is my first matrix, right? The other matrix could be, let's say, 2, 3, 1, 5, 4, 6, 9, 7, 8. So this is my second matrix, right? One thing to note here is that the shape of these two matrices are the same, right? So both of these have a shape of 3 cross 3. So this is my matrix M1 and this is my matrix M2, right? These are my two matrices. Now, one very common operation to do between two matrices is we can actually perform matrix addition, right? So we can do M1 plus M2. Another thing that we can do is matrix subtraction. We can do, sorry, this is going to be 1. Then we can do matrix multiplication M1 into M2, and then we can also end up doing M1 divided by M2. We can also do M1 percent M2, and the list goes on, right? So these are the matrix operations that we can perform. Now the good thing is that for you to be able to do these, you don't need to write specific lines of code in terms of nested for loops. These matrix operations, these matrix operations are pretty much available in NumPy, and you can just use your arithmetic operations to do this. Operators, arithmetic operators to do this, right? Let me give you an example. Let's say you want to add these two, right? So how will the addition look like? If you're adding these two matrices, right? If you're adding these two matrices, then what will the resulting matrix be? So it will be you add the 0th row and 0th column element at that position from the first matrix with the 0th row and 0th column position value from the second matrix, and that will be your 0th row 0th column position value for the target metric, right? So this is going to be 3. 1 plus 2 is equal to 3. This is how it will be. Now you will continue to do the same for all the other position values as well. So 2 plus 3 is equal to going to be 5. Now 3 plus 1 is equal to going to be 4. Let's do the same quickly. 4 plus 5 is 9. 5 plus 4 is 9. 6 plus 6 is 12. Now let's do the same for third row. 7 plus 9 is 16, 8 plus 7 is 15, and 9 plus 8 is 17. So this resulting matrix is nothing but M1 plus M2. And that is how matrix addition works. You can also do matrix multiplication. Let's quickly do that here and see what the outcome is going to be, right? So how do you do matrix multiplication, right? Again, the same rule applies. You multiply all the values at the same row and column level and then put them in the resulting matrix, right? So for this to happen, we will take this element and we'll just multiply. So when you do this, this becomes 1 into 2, 2. Now here we take 2, from here we will take 3. So this becomes 2 into 3, 6. We take 3 and 1, 3 into 1 is 3. Same ways, we do the same for second row as well. So 4 into 5 is equal to 20, 5 into 4 is equal to 20, and 6 into 6 is equal to 36. Let's do the same for the third row as well. So 7 into 9, 63, 8 into 7, 56, and 9 into 8, 72. So now this matrix is coming out of M1 into M2. And same ways we can perform any of these operations. So we can perform a addition operation, we can perform subtraction, multiplication, division, or we can do a percent operator, right? Means give me modulus, right? Percent is for modulus or remainder. So once we have used two matrices with these operators, what happens is you get the outcome as the third matrix, and this is going to be based on the operator that you are using here. So let's quickly do this in Python and see how it works, right? So let's do this. Okay, so what we are trying to do is try to generate two random matrices, right? So the first matrix is going to be based on numbers from 1 to 10, and what we are taking is 9 samples. So basically this function ri, which is random integer, is going to give us 9 different random integers between 1 to 10, right? And we are reshaping this into a 3 by 3 matrix, right? So when we do this, we are storing it in mat1, which is my matrix 1. We are doing the same operation again, but then we are again, next time we are saving this into another matrix called mat2. Okay, so I will need to actually import numpy as well, and now run this. What is happening? Okay, let me correct this. So we should probably change this to random. I'll just change this. Yeah, np dot random dot rand. Cannot reshape array of size 10 into shape 3 by 3. Perfect. Now we will copy paste this to here as well. And now this is fine. So what is happening now is it is giving you uh, just correct this. Okay, so now this is correct, right? So what we are trying to do is we are trying to get random integers between 1 to 9, and we are getting 9 such numbers. And then we are reshaping mat1, which is matrix 1, into 3 by 3 matrix. Same thing we are doing for mat2 as well. We are taking random numbers 1 to 9, and then we are reshaping the matrix that we are getting into a 3 by 3 matrix. So this is my first matrix, 2 6 8 5 7 6 8 8 8, and this is my second matrix, 1 3 3 2 6 6 and 2 8 1, right? Now what do we want to do? We want to do some of these uh, universal functions, right? So let's see if these work out to be correct, right? So the first one that we are doing is very simple, mat1 plus mat2, and the second one that we are trying to do here is a multiplication operation, mat1 into mat2. So let's see how it works. So the first one, right? See, 2 plus 1 is equal to 3, 6 plus 3 is equal to 9, and 8 plus 3 here is equal to 11. And this is the way, exactly the way I showed you here as to how the addition works. The same way, if you look at the multiplication operation, let's do the third line for this, right? And figure out if this is correct, right? So the third line for matrix multiplication should be 8 into 2, 16. So this is correct. 8 into 8, uh, this 8, so 64. And then it should be 8 into 1, which is 8. So this is turning out to be correct. So this is how you actually do your matrix arithmetic, right? This is how you perform your arithmetic operations on the matrix. One thing to remember is that the size of the shape of the matrix should be same, right? If you perform these operations on different shape, then that is not going to work out because the number of elements are not going to be the same. So it needs to be of the same size. Now the way we have done addition and multiplication, you can also do division operation, right? And this is simple. So let's take one example quickly to see if this is working correct or not. So 2 by 1, what are we trying to do? We are trying to do, let me first execute this, right? So we are trying to do 2 divided by 1, so this is 2.0. Now we are doing 6 by 3, which is 2.0, and now we are doing 8 by 3, which means 2.66, right? So this is what we are trying to do here. Okay, so this is actually my matrix division operation. Okay, so moving forward, the other thing that you may be required to do at times is that you may be required to do some addition or scalar addition to all the values within the matrix, right? So how can we do this? I think I already showed this to you guys yesterday, right? Where if you want to add any value to all the elements of the matrix, then you can just write that constant value plus mat1, right? Or any matrix. So what is happening? It is adding 100 to all the elements, right? Let's quickly check if this is working fine. So my first row of the first matrix is 2, 6, and 8. And actually, if you look at the this matrix where we are adding 100 to mat1, it is actually 102 instead of 2, 106 instead of 6, and 108 instead of 8, which means that my all the elements of the matrix are getting incremented by 100. So this is working fine as well, right? So it is very simple, guys. It is definitely not complicated at all. It is, think of it this way, right? That these arithmetic operators are not only allowed on single, variables which store single values. You can also perform the same set of operations on a matrix as well. The only requirement is that it should be of the same size and shape. So moving on, what we can do is we can also calculate the square, the cubes. You can do all of this, and you can also do square root, cube root. You all of these are permissible operations within uh, matrix operations. So if you look at it, what is happening here? Um, the first one is a cube, right? So first one is a cube. M when you do double when you use the double multiplication operator, what is happening? You're trying to do raised to the power, right? So mat 1 raised to the power 3 is cube, which means mat 1 into mat 1 into mat 1. So let's see if this is correct. At least let's check it for one of the rows, right? So what is my first row? It is 2, 6, and 8. So cube of 2 is going to be 2 into 2 into 2. So this should be 8. So this is fine, right? What is happening here? 6. So 6 into 6 is 36, and 36 into 6 is 256, right? 216, sorry. And this is actually correct. So that ways it is actually doing a cube. And here what we are trying to do, we are trying to again do the same thing, but then we are using the power operator. Sorry, power function. Power function is also used to uh, calculate square or cubes, right? You can also do fourth power. You can also do raised to the power 5. You can also do raised to the power 6. I mean, the choice is yours. You can do whatsoever with this, and all of this is going to actually work. Now, this is just a repetition, so I'm just going to take it away. This is not going to be of any help, or you can just ignore this. This is fine, right? So we have covered all till here. Do let me know, Gangesh, if you have any questions here. Gangesh, any questions?
So, no, no, no,
Okay, all
no
right.
questions.
All right, so this is what we had left out yesterday from our NumPy class, right? So that is what I have covered now. And these operations are very simple. You can just define your matrix, and then you can, after defining the matrix, you can just do your mathematical operations, and this is going to actually work out perfectly fine. So with that, NumPy is covered.